Hello, let us look at number 4 from year 2010, Form A. Alright, so let's get started here. I'm going to give you a little bit of time for you to read, and then we'll try to get this question together. So we have region R be the region in the first quadrant, as you can see. Y equals 2 radical x. I believe that's the curved line right over here. Now, horizontal line y equals 6, right over here. Y equals 6. Now, y-axis given. All right, find the area of R. How are we going to do that? We're just going to solve it over here. Area can be simply calculated from 0 through 9 for upper line minus bottom line. So 6 minus 2 radical x dx. Then obviously 6 becomes 6x. And here, minus 2 was already there. You can consider square root of x as x to the 1/2 power, and then using the reverse power rule, then you might be able to understand this one a bit better. Adding 1 to the exponent, which is we end up getting x to the 3/2 power, and then multiply by its reciprocal, which is 2/3. Goes from 0 through 9. Alright, so if you have to write this one in a bit better look, then we're going to end up having 6x minus 4/3 and x to the 3/2 power, 0 through 9. Once you plug in 9, we end up getting 54 on the first portion. Now, second portion becomes, here we have 9 square root of, because over 2 is square root of 9 becomes 3 to the third power becomes 27, but you got to divide that by 9. 3 becomes 9, but you got to multiply that by 4, so which is 36. Then we end up getting 18. Alright, so let us look at part B. Right, but do not evaluate the integral expression that gives you the volume of the solid when R is rotated about the y equals 7. Where's y equals 7? Since this is equal to 6, maybe y equals 7, let us assume that it is around here. Then what we need to do is this. We need to figure out the radii. So what is the, when this thing is revolved around this way, then what is the outer shell or outer solid? This will be the radius that is formed by the outer solid, which means from 7 to all the way here. So here in this case, the radius will be 7 minus 2 radical 2 radical x. How about the inner solid will be right over here. 7 minus 6. Difference between the axis of rotation and then the line itself. Then what we end up getting is this. The volume will be then equal to pi 0 through 9, and then outer, so which is 7 minus 2 square root of x square minus 7 minus 6 square dx. That becomes the expression that gets you the solid volume of the solid. Alright, let's look at part C. The region R is base of a solid for each y here, where y goes from 0 through 6 in this way. So why don't I try to erase this picture just a little bit, or erase this picture just a little bit and then try to figure out the rest. Alright. Now, the cross section of the solid is taken is perpendicular to the y-axis. Alright. Now, is a rectangle whose height is 3 times the length of its base. Alright, that means this is the base of the rectangle, but height will be 3 times of that. You have to imagine that this is a rectangle coming out of your screen. And it's going to just line them up in this particular way. Now, then what is this length? This length, in fact, is the value of x from this function. So what is x? Then dividing it by 2, we get to realize y equals 2 square root of x. That means square root of x will be equal to y over 2. And therefore x becomes y squared over 4. That's the x value, and that is the base of the rectangle. Now, then let's look at part C. And the volume in this case is collection of the rectangles, where the base is simply y squared over 4, and height is 3 times the length. That means 3 times y squared over 4 dy, and which goes from 0 through 6. That was the boundary. Now you could just leave it in this way, or you can just rewrite this one as from 0 through 6 of 3 we have y squared over 4 to the square dy. Alright, that's it. I'll see you guys later. Bye.